Okay, so let's in a weird way, we're going to pick up where we left off, but we're going to be transitioning tools, and we'll actually make some references to what we were already working on. So I'm not sure we're completely done on that side yet, but we're in our transitional period. But we're going to start looking at another tool. If you want to go ahead and get it downloading, or at least make a note to download it later, you won't need it today. We're going to be talking about it for this class and next. Probably you'll probably do something with it, maybe for homework over the weekend or possibly for Friday, but we'll see. So the website is unity.org, or I'm sorry, unity.com. And you want to go to get started. Individual, and you can choose a student or personal, doesn't matter. We're not going to be doing anything special with it. But in any case, once you get it, the thing you're going to be downloading, you'll download it for either Windows. If you have Windows, I'm on a Mac, so I downloaded it for Mac. They also have it for Linux. But you want this product called Unity Hub. So Unity Hub is kind of a package management software where you use it to install whatever the latest, greatest version of Unity is. The default settings for it, so if we go through, just pretend like I'm doing this. So once you first get into Unity Hub, you're going to want to get one of the most recent official releases. So under installs, go to official releases, and get something that says LTS next to it, whatever the latest, greatest LTS for your platform is. I actually think the latest is 20.3.31. So I'm actually a little out of date on this. But that's okay. So get whatever the latest, greatest LTS is. There are newer ones, but LTS is long-term support. So the idea is that any tutorials and stuff you look at probably will work on that. It's not using some thing that just was invented 2 minutes ago or something like that, even though probably a majority of stuff will work on any of them. Unity hasn't drastically changed over the last 2 or 3 years or something like that. All right, and that's going to be, probably a couple gigabytes download. So do that overnight or something like that. Let's see, so that's what they're calling the editor. What comes with that typically is Visual Studio. It does on the Mac. I think it does on Windows. I haven't installed it recently on Windows. If you don't get Visual Studio with it, you can go and just download a free version of Visual Studio. Let's see if it comes with it first, because that'll be what you'll use for writing your scripts. And we're going to see some examples of that today, just to kind of give you the overarching thing we're looking at. So between now and let's say next class, just so you can follow along, go to unity.com, install the latest Unity Hub and latest LTS editor. I believe the latest LTS editor is 2020.3 dot something. I think it's 31, but something like that. Should come with Visual Studio, but you can also install this separately if you want. You can tell Unity to open up whatever you want it to open up for editing your code. If you want to edit your code in Notepad, you can do it in Notepad. So it's more about just convenience of a text editor thing. All right, so get that stuff installed on your computer for next class. You'll be able to kind of go along with what we're doing. We're going to start off with some pretty simple stuff, so I'm just going to kind of give the overall crash course for today. So first of all, what is Unity? So Unity is what we typically will call a game engine. So game engines come with tools for, and Unity is a 3D game engine, so it's originally designed for making 3D stuff. Any of your video, I mean, a lot of the latest, greatest video games that come out, if you've played them, sometimes when it first launches, it says Unity on it. That means they made it with Unity. If it doesn't say that, that doesn't mean they didn't make it with Unity. It just means they maybe paid them more money to not have to say they made it with Unity. But in any case, it's a popular game engine. The two cool kids today are Unity and Unreal Engine. I'm probably a fan of Unity over Unreal. I think it just has a bigger developer community that's starting today. So more recent stuff, where Unreal, I think, is a much longer history of Unreal. It came from it was the internal game at a game company for years. And then they released it. And so it's not that one is better or worse than the other significantly, but I think Unity is probably better supported online. Let's go with that route. All right, so this is tools for 3D stuff, including objects, physics. And physics is really the big thing. I mean, when we say game engine, we're probably mostly talking about physics. Do all the crazy math so that if something gets hit by something and it bounces off, I don't have to make up the math that makes that look real. Game engine does all that for you. And we'll kind of see that small example today. I think I told you before, I am not overly artistic, so we will, be working with a lot of generic cubes and, and things like that. But there are, at some point, we'll look at the asset store and we'll bring some stuff in. If you wanted to go through it, there is a learn Unity tutorial thing where you can actually make like this Lego game. I went through it. It's actually pretty decent, but it kind of covers things in a order that's not really compatible with where I want to go with it. But if you are interested in it, you can do their Lego mini, I think it's micro game, Lego micro game tutorial, and make a Lego game. But we'll see. So Unity is a one-stop shop for creating these 3D games. Unity also supports 2D, but it wasn't originally created for 2D stuff. So think of it as a 3D game engine. Gives you everything you need to handle animations, physics, all sorts of stuff like that. So all you have to figure out is what does your game actually do? You're the creator. It does all the magic behind the scenes, and you just connect some of the dots with your scripting. All right, so we kind of have two separate sides to this. Up to this point in all of your classes, 200 and then 250, we've been creating our own non-existent user interfaces, right? Mostly like a text-based menu thing that says, press 1 for this, or, type and throw a rat if you want to throw the rat from one room to another room, like really high definition stuff. And part of that is, and at the hackathon, at least the attempt was to look at building a graphic user interface for Java. And for those of you who had groups that actually did that, you saw that it's not necessarily the friendliest thing in the world. Mostly because it came from a point in time. Java's always missed the mark with some of those things. It's actually pretty surprising Java's still so popular. It's just that big companies happen to adopt it. But Java has always been behind the 8-ball when it comes to having fully integrated tools, where you have a single tool where you have your graphic user interface hooked directly to your code and things like this, even for like doing web development or something like that. Where the antithesis to that that's been popular, it's been good, might be like Microsoft's Visual Studio. Microsoft Visual Studio, you open it up, you want to make a GUI C# application, you create a GUI, you drag a button out there, you double click on it, you write the code for what that button does. It's pretty self-explanatory. Kind of lends itself towards maybe writing some poor code, because it's always, you know, you have text box 1, text box 2, text box 3, it just names the things that, and then programmers are often too lazy to change it to something like what it means, like, you know, login name .tb or something like that, or underscore tb for that text box, instead of just calling it text box 1 or whatever default named it. But in any case, Unity brings these tools together and allows us to create a user interface, at least gives us the tools for creating the user interface. You still might not be, you might be like me and not be gifted at making beautiful user interfaces, but it gives you all the stuff to at least fake it. All right, fairly easily. All right, so let's just start by just looking at a couple of things in Unity, just kind of what the starting point is. Okay, so I'm just going to go through the thing as if I was going to make a new project. I actually already created a little tiny one that we can reopen. But when you first say I want to create a new project, if you go under learning, here's those learning templates. These are kind of tutorials. We're not going to go through these individually, but if you wanted to play around with it, the Lego micro game is pretty graphically advanced. It like looks like a Lego game you'd pay money for. These other ones are, they're fine. Better than I'd be able to do, but these aren't something you'd find on your Xbox. But you can learn how to make a 2D platformer, like a Mario Kart type game, or like a first person shooter type thing. But this is a micro game, so it's a very small, like one room type thing, just giving you the basics, but it covers about 30 different things, where I want us to kind of stumble in with about 6. So the reason we're not doing those is it kind of goes through too much stuff. So usually want to start with the core. There are some starting points for some of these things, and we might actually, depending on where we get in the semester, we might actually do something with the VR headsets and take some of our skills from Unity and do something with VR. Because one thing we're going to learn here relatively quickly is that the difference between writing a normal 3D game for the computer versus a virtual reality 3D thing is the camera. So we're going to see here in a second that when you first create a scene, you get a single camera. Think of it like a cameraman standing in the room. You know, whatever he's pointing the camera at, that's what the player will see. Okay. Well, the camera just needs to be a little bit more, I don't know, complex if we're in VR, because it's not just watching the person, it's also paying attention to how their head moves and how their hands are moving and those controllers and stuff. But it's good for us that there's already built-in camera rigs for VR that you just swap out the normal camera and get a much more expensive camera and drop it in and say, okay, now you watch that. And whatever we see the camera doing, or whatever the camera's pointing at, is what you would see inside your VR goggles. All right, so, and there's some starting points for some different things. One interesting thing for those of you who are going to take this Unity skill set and kind of run with it and try to do something, you know, cool, maybe create your own game, something like that, is, and this kind of gets back to something we spoke about early on with Java, that Unity is cross-platform. And that means really two things in this case. One is that you can develop for Unity, whether you are on a PC, a Mac, or a Linux. The Unity editor is available for all three, but you could also deploy to a whole bunch of different platforms. So you create your game using Unity. Unity is the ecosystem you're building your game in. Then you say, okay, well, If I'm on Windows and you want your game to just be available on Windows, you can export it as a .exe that'll run on Windows. If you want to have it run on Mac, you don't have to change anything. You would just export it as a Mac executable. If you want it to run on Android, like a smartphone, you'd probably want to change your resolution and stuff because you probably designed it for a bigger screen, different form factor, but you can change some of that stuff and then deploy the game for Android. Same thing with VR, stuff like that. So you don't need to write it 20 different ways. You just have to keep in mind kind of what screen real estate do you have available to you in terms of like, what is the camera able to see at any point in time? All right, so write games on Mac, Windows, Linux, can deploy games to Mac, Windows, Linux, iOS, Android. Now I'm going to say for iOS, really this is Mac only. I think there are some hacks you can get it to work. Otherwise, the reason for this is that when you do iPhone programming, you need to use a tool called Xcode on the Mac, and that's not available on PC officially. So Unity works with Xcode to actually produce the iOS executable. But there's some ways you can pull it off on a PC, but that's more of because it's Apple's thing. It's not a Unity weakness. It's the tool that it leverages weakness. So you can do Android on any of the platforms, VR across the board, different kinds of VR. So you're not very limited. You become an expert at Unity, you can do all sorts of cool stuff. All right. And Unity still lends itself to the similar type of various skill sets we've discussed. So, I mean, in here, our focus is going to be more on the programming side of things. So we're not going to be paying that much attention to how awesome our interfaces look, but we will have an interface instead of just text-based. So we're upgrading at least a little bit there. But there are plenty of people who are game programmers who focus more on the logic of the game. Then there are other people who maybe are animators. So we have several animation classes where you maybe use Blender or Maya, something like that, to actually create, animations for characters in a video game. Those are things that you can import those assets into Unity and then kind of plug them in. So the programmer didn't have to have made the animations. They just are working with pre-created animations that another skill set may be created. Make some sense? All right, so if you become awesome across the board with all sorts of different things in Unity, that's great. But I would say still expect that you're going to lean towards one skill set. Our focus in here is going to be more of that programming skill set. All right, so I would pick the 3D core as our starting point. That's what we're doing pretty much the whole time. You say create project, and it's going to bring you into something like this. And actually, let me just get rid of. Oh my. It's not going to go away. Why? Quite a bit of flicker. I wonder if it's something with Zoom. I can't make my I mean, I can click on these guys, but I can't actually make my cube disappear. Not overly important. Initially, you get this scene without having the cube in it. Actually, let me just do this. We'll just start from scratch. I'll create a new project, 3D project. All right, so we have something that looks like this. Now, there are different ways for you to kind of organize your interface here. The default is it has all of the objects that live in your interface are over here on the left. Down here at the bottom are your assets. This is going to be like graphics, animations, scripts that we're going to write that we attach to objects that will live in the scene. I think in class at some point I referenced that when we get to Unity, we almost think about it like scenes in a play. So the scene that we're working with here is called sample scene. We have a camera, we have a directional light. So it's almost like you just walked into a room and it's set up for a show, a shooting, right? And now you're going to start bringing objects, bringing things, actors into the scene. And then we're going to, put assets on them, dress them up, make them look a certain way and things like that. And so, for instance, if I hit this little plus sign up here, we can create all sorts of different game objects. So the default thing, if we want to think about it from a Unity perspective, game object is the minimum real thing that can exist in a scene. You can think of this as kind of like the object class in Java. It's the most generic thing that can exist in a scene is something called a game object. Now, by default, I'll just show this through here. If I create a empty game object, I get something that looks like this. If I go ahead and run this, so it put it in the very center of the scene right now. So the camera's pointing at it. I hit play. There's my game currently. I don't see anything because even though I did just create a game object, it doesn't have a visual component to that game object. As opposed to if I hit the plus sign here and I go to 3D objects and I say put a cube in there, it'll also drop that at 0, 0, 0 right in the center. Now, if I hit play, we'll see that cube sitting there in the game because the camera's still pointing at it. Okay, so the default position of the camera is to point at the center of our scene. A good way to look at this. So up here in the upper right hand corner, you have this like kind of directional thing. If you hit on Y, X, or Z, it'll show you on that. So right now we're on the Y, so we're looking straight down. So you see the boxes right here, the camera is right here. So that is we're lined up. We go on X, we see that the camera is actually slightly above, kind of angled down. So we're shoulder height, something like that. And that's Z, we're kind of on the other side, but that's the depth, the third dimension. But at least initially, looking down from the Y-axis is a pretty decent way of just seeing your stuff line up. You'll get better at that with some practice. I haven't used it in a while with a mouse like this, so we'll see how bad that ends up being. But it's pretty easy to maneuver around in here with a normal mouse where you can click on the right button and you can kind of drag around and manipulate, but it's doable on this. All right, so whatever the camera's pointing at, that's what you'll see. Now, just to show you the difference, so we have two new things. We've hired two actors for our scenes. We got this game object, this generic dude, and when you see him over here on the right is the inspector. This is the details about that game object. And we see that that game object, the default is he only has something called a transform. Now the transform is kind of like it's among the bare minimum things that any game object must have. And that is, where do you live? What is your rotation? And what is your scale? So the transform is 3 vectors of 3 values. Now the word vector sounds scary, but all this means is we have a position X, Y, and Z in 3D space. We have a rotation X, Y, and Z in 3D space, and that's radian rotation. And then we have a scale. Normal scale is a 1. If I change all that scale, all those scales to be 100. So right here, we have a scale of 1. Let's just change them to, I'll do X on a 10. So now 10 is, X is stretched out. Y is stretched out. Z is stretched out. So now our box is 10 times bigger than it used to be, because I scaled it up. Okay, same location, its center point's the same location. Its rotation is still nothing, but now it's 10 times bigger than it used to be. All right, so that transform keeps track of 3 different global pieces of information. Where are you? How are you rotated? And what's your scale? I'll take this back down to 1. All right, so now when you look at, I just clicked on the game object, the empty guy, you see he only has a transform. When I click on the cube is something we see. We see there's some other stuff hanging off the cube in the inspector. Not only do we have a transform, because all game objects have to be able to exist somewhere in the scene, even if you can't see them. Okay. We also have this mesh filter and a mesh renderer. So the renderer is the thing that allows us to see it. So if I turn off the mesh renderer, we won't see that dude anymore. Box is gone. And you should be able, I think you can do it during real time. If I come in here and turn it on, you see it back. But one thing to keep in mind, that any changes you make to the inspector over here while the game is running will be undone when you stop the game. So you can kind of play with it. You can say, okay, well, I wonder what this is going to do. I wonder what this is going to do. So you start the game up and you say, oh, well, I don't see it. Why is that? I clicked on mesh renderer and re-enabled that feature and it showed up again. That allows you to kind of mess around with it. You can also, change the size of things. But as soon as you stop it, it reverts back to where it was before. Just keep that in mind if you go and make a whole bunch of changes. There is ways of copying that stuff where you can copy it before you stop it so that you can then paste in the changes you made later on. And we'll see that at some point. All right, so, but automatically that cube came with not just a transform, but it came with a way for us to see it. And it also came with something called the box collider. Colliders these are components. So we can add components to a game object. So the default game objects that, like a cube, comes with a renderer and a box collider. Renderers let us see it. Box colliders, or any kind of collider, let us deal with it bumping into other things. Okay, and becoming aware of it. We'll mess around with that sometime soon, where we have things smashing into each other and us making decisions based on that happening, right? Okay, so at the very end, then we have this default material. So this is, it's the default material is this whitish looking thing here. That's why the box is white. You can create new materials that you can download them off the asset store and have ones that look like bricks and all sorts of stuff, but we're going to keep things, you can be as imaginative as you want with it, but we're going to keep it pretty simple. Okay, so now this is what we look like right now, even though we technically have a game object and a cube in here. I'll go ahead and get rid of that game object. So now we're just sitting with the cube. So in the studio right now, we have a camera, we have a light, and we have a cube. Those are the things that are sitting in our scene. All right, Now, when I click on cube here, and you can rename these things, and you can organize them. So as we start getting into more complex things, we'll look at some of those things. Just looking at a high level right now. But if I click on cube and I go over here to the inspector, paying attention that the game's not currently running because I want anything I'm about to do to stick. I did that for a long time when I first started doing Unity years ago. That's a feature has not changed. I click on add component. There's a whole bunch of stuff that we can add to game objects. We can add audio stuff, effects, events, layouts, yada, 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 yada. There's physics stuff. So here's all of our different kinds of colliders. Different colliders have different shapes, like a capsule collider is almost looks like a pill, looks like a capsule. So it's rounded on the edges. So maybe, you know, if you have like a player in a game, he's not moving around as a box in terms of what he bumps into. He's running around where he kind of curves in at the bottom. So, you know, that might be a better type thing. But under physics, and something I mentioned a little bit ago, is one of the things that Unity does is it does probably the most important thing Unity does is it does all of the physics math for us so that we don't have to invent all that math that you learn in the physics classes. Okay. So a very important thing for us here is this thing called a rigid body. Okay. So we just upgraded our game object. When he first came into existence, he just had a look. He looked like a cube. We had a mesh on him. He rendered all that stuff. But now we've made him a rigid body. Hit play. You'll see nothing's probably changed. Oh, it does. Gravity's turned on. I'll show you turning it off in a second. But so all I did is add the component rigid body. So now we've given this dude mass. He's a thing now. Okay, we could throw stuff at him and bad things could happen. And by default, for a rigid body, you could decide what's his mass, how much drag is there. These are some things about, you know, if you have two objects that are kind of up against each other, what's the what's the impact they have on each other in terms of slowing each other down and stuff. It does all that math for you. And then we have a checkbox that says whether or not to use gravity or not. By default, gravity is turned on, which means that this box that is there will instantly have the force of gravity pushing down on it. Okay, so now if you're holding me up here in the air and somebody hits play and the world starts spinning for me and gravity's turned on, I drop to the floor. So this guy attempts to drop to the floor, but the problem is there is no floor. So he just falls forever. And you're actually watching him. This is the our on the y-axis. This is how far our cube is falling. And it's going to go on forever. It's just going to keep going. All right. But now we could decide, you know what? I don't want gravity to play into my game here, but I still want the thing to be a rigid body. I want mass to mean something. Okay. You kind of think about something like maybe you're making like a bumper car game or something like that, where all the bumper cars are going to be sitting on the ground, so we might as well not make it do all the math to make that a thing. They're just sitting next to each other. But if you have a really big bumper car and it hits a much smaller bumper car, the really big one has more mass and probably is going to have a little bit more ability to throw its weight around, so to speak, right? So you might still choose to use a rigid body, but not necessarily take advantage of the physics feature of it. All right, so for right now, I'll just leave, actually, yeah, I'll leave gravity off for this guy for a second. All right, so now we think about other components that we can add here. We're doing on time, okay. And I can add a script to this guy. So what I'm going to do over here under my assets, and sometimes, you might create a folder in here. I might say a folder, I might call it my scripts folder. This is just human organization, something like that. If you want to lay out this stuff in your assets folder a little bit better. So maybe inside of scripts, I'll go ahead and right click and I'll create a new C# script. And let's call this guy the box script. Let me go ahead and Visual Studio here. All right, so I made this box script here. So I'm going to go ahead and double click on this guy, and I hope it opens in Visual Studio by default. Seems like something's going down. All right, so this installed Visual Studio 2019 for Mac on my computer, so I presume it'll do the same thing for Windows. All right, so now it opened up this script. All right, now right off the bat, you should be able to look at this and see this looks a lot like Java. There's some new words in there that you haven't seen before because we're now switching to this new tool, but public class, we kind of know what that dude is, right? The name of my class is box script. This guy in C# you use this colon thing. In Java, it's the word extends. So this guy inherits from something called a MonoBehavior. So a MonoBehavior is kind of this important active element in Unity. And MonoBehaviors, our most important thing is this guy right here. We'll talk about it in a second, but it comes with some starting things. Okay, so what they give here is any object that has this script attached to it, when that object first starts, the start function will occur. And that happens one time. So if there's any sort of stuff we want to get the ball rolling with, get everything started, we can do that inside of start, but this only happens once. Update though, this guy, this is called every single frame of your game, which means a lot. Okay, depending. Now there is a version of update that gets called it's called fixed update, and that gets called 60 times per second. Now the reason for that is you're trying to make if you're a video game writer, you're trying to make a decision, and you want your game to kind of perform the same regardless of whether you have somebody over here with a really fast computer versus somebody over here with just an okay computer. Using update, the person with the really fast computer update's going to get called more often because the number of frames per second that's being rendered for that game might be 200 frames a second, let's say. So that means technically, because we would probably put our logic in here for button presses and jumps and moves and things like that, that's probably going to be inside of update. Technically, that person would have more opportunities. Their reflex time would be better because it's hitting that update method more often, as opposed to a function called fixed update, which is just guaranteed to happen once every 60 seconds. Or I'm sorry, 60 times per second. Sorry, 60 times per second. But regardless of how good your computer is, it's forced to happen 60 times a second. But this guy, we would probably call our game loop. It happens often. All right. So things that we would put in here is logic that we are recognizing occurs all of the time inside of our game. So what we'll do next time is, so I'll expect everybody to go and get this stuff downloaded or whatever and get it on your computers. We'll pick up from here, and the very first thing we're going to do is we're going to start working with these things called vector threes, which is linear algebra type stuff, but we won't have to do the linear algebra because again, game engines do all the math for us. So we're just going to say, hey, this is what I am. This is we're going to have a vector for velocity, and we're going to say we want that box to go up in the air. And we're going to keep adding to that velocity every single frame. We're going to see it take off. All right, but that's something that we did related to it. Then we're going to start putting button presses and stuff like that in there. All right, questions, comments, concerns, bribes. All right, so everybody has the details for getting the tool. All right, and we'll spend next class looking at this in some more detail. Tuesday. Tech Talk is tomorrow. Yeah, Tech Talk is tomorrow with SkyGen USA, and they're going to, this one's in person. So it's at the by the makerspace. Yep. And remember, it's required, but there is an alternative assignment if you think it's a waste of your time or you have other obligations. There won't be a Zoom link for it. Yeah. But SkyGen is one of our biggest employers. Yep, by the makerspace. But SkyGen, we have a whole bunch of students who have interned there, work there full time now. It's a good one. It's one you don't want to miss. And their main employer, the person that hires directly for us, is their senior software engineer guy. He's the one who's presenting.